Hello everyone, welcome to my Gephi tutorial. In this tutorial, I'm going to show you how to get started with Gephi, but I'm going to show you the method that I've used to create plots in Gephi, which mostly involves first starting in RStudio, processing the data and saving that as a graph object and then uploading that to Gephi. So if you don't have Gephi yet, you can install it here via this link. And it's a pretty straightforward install. You would just click on the download button and it's pretty much available for both Mac and Windows as well. So now I'm gonna go onto my RStudio. I'm gonna show you the data and how I've generated a graph object for Gephi. Okay, I am gonna be starting off in RStudio. I use RStudio to do all of the calculations and to develop the network relationships, and after that save them as a GraphML file. GraphML is a format that is accepted by Gephi. It's one of the many formats. You can also save it as a CSV file, but I find that GraphML allows you to upload so many more features that you would have done in R into Gephi. So here is example I'm using, which is the Marvel Cinematic Universe characters data. You can get this data on Kaggle, and you can also get this code via my GitHub, and I have provided the link below. So in my GitHub, there are specific instructions on how to load the data from Kaggle. And yeah, so let's get started. I'll briefly take you through the code. So the code uses network-vis, igraph, widr, and data.table packages. And first I read in the data. Let's load the packages first and read in the data. After which then I merge the two data sets together because one data set only contains the character IDs and we want the names as well. So that's why this function is here, and that's what it does. Calculating of word pairs. Word pairs is an algorithm that's available in widr package, and what it does is calculates how frequently one character appears with another character based on comic book. So that's the comic book ID that I've got there and the name, the character. So that's pretty much what it's doing. And there's different ways of calculating relationships. You could also use correlations if you want to, but this one's very simple, just based on frequencies. And this is what you get. You would get an item 1, item 2, and the number of times they appear together. So it's character 1, character 2. So X-Men together with the Wolverine 805 times, which is no surprise at all. And what you can see is that you have like a bi-directional relationship. You have X-Men to Wolverine to X-Men. So if we just want one direction type of network block, which I want to have, what I would do is use this index to remove all the duplicates. And that's when I get a nice, if we visualize this again, get a nice, more clean table with only one direction relationship. So you have X-Men to Wolverine. So that's what we want. Well, that's what I want to show in this exercise. And I have specifically renamed it. Gephi really knows what these names are. So it wouldn't understand item 1, item 2, and n. So it's suggested that you rename your file before you save it. And what this line of code does then, this is from igraph, it turns it into a GraphML object, and this saves it. And you can really see that the object is a little bit more different from your normal data table. And you can explore this if you want, but I'm just showing you a little bit of 101s. Okay, so now we have the data saved, and we have run it through RStudio, and now we want to move to Gephi so that we can visualize this large network. So I am now in Gephi, and what I am going to do now is upload the GraphML file that I generated in R, and you can already see it. So just go to this overview window. There you go. You can see it as a big square and with not much information. And this is typically how a large network would look like, and you would have to format it so that it gives some form of structure that you can interpret. And that's what I'm going to show you, but I will only run through the basic stuff. Okay, so if you go to, I originally start by going to clicking on statistics, and I run the Gephi modularity algorithm. So this puts your different nodes into groups, known as clusters. And what we see now, it's got, the groups are called communities. What you see here, we've got 10 communities detected, which is not bad considering the amount of nodes that we have. That means we do have some structure in our data, and it could be grouped pretty well. So that's close, and it feels like nothing happened. You would have to then go to nodes here and click partition. You have to specify you want it by modularity class, and I would literally select my own palette because it's default to 8, so we need 10 communities. Generate. You can have different themes. It's pastel theme. I don't really like the pastel theme, it's a little bit too light. And so let's use the default, and we click apply, and there we have it. And the next functionality I'm going to show you is how do we spread these, and we do use the layout functionality to turn it into a different structure, to give structure to the network. And that's, you've got different layouts, but my favorite layout is this one. So that's when you see the magic happening, and you see your network forming some structure and the clusters coming together. So this is pretty cool. This is a very cool feature. And we can see that the Marvel comic clusters, it's a very tight network. It's not a very loose network. And there's probably like one character in between here that's just like keeping every other connection so tightly packed with each other. And I can already tell you that character is like Wolverine or in Spider-Man, one of the two. Okay, so now we've got a little bit of structure here, but we want to know what character is what character. We want to add labels. We want to be able to interpret a little bit more. How we get to do that is you would go to the data laboratory. The data laboratory allows you to edit your data. You can edit your node names and labels, and you can also edit the modularity class if you think that something belongs to the wrong one. So you can manipulate your graph manually here. It also has a function for the edges as well, so you could do a little bit more tweaking if you need to. The only tweaking I'm gonna really recommend and do is the labels, because we want the labels to show as the name. So if I go back to my overview and I just click to show this icon here to show labels, it shows them as the node reference and not the name itself. And that's why I wanted to go here, and to get that we just click here where it says copy data from other column, name, label. Yes, we want the name to be copied to the label column. Now we see it's already changed, and it already doesn't look so pretty, and it already looks like, how do we actually start looking at this? There are various methods of filtering data in Gephi. The best way to filter data I have found is it's going to topology. So if you go to filters here, to go to topology, and you can filter it by degree range. So degree is like based on the node that's got the most connections to it, the most edges. So if a node only has edges, more than 150 edges, we want to display it, so we can filter it. And then we can only see the high degree nodes, but we can't really still see much here. What I then do is I choose another layout to spread out the labels, and this layout is called label adjust. So if you run it, it starts to spread out the labels into format that's readable. And yes, and something that's also quite significant here is that all nodes appear to be the same size, or you can't really see them defined that well. and you might want to change that and bring out the high degree nodes a little bit more. How we do that is you just go to this, back to nodes, and then you go to ranking, choose attribute, which is the degree, and if we already say apply, you can see that the high degree node's already coming out, and we can make that bigger by changing it to 150. See, they already start to come out, so you can really see which characters are more relevant. And another way you might also still want to spread out this network a little bit more is by expanding it. So expansion also allows you to expand it a little bit more, and you can see the different characters again. So that's pretty cool. And yeah, and I think another one is changing the label sizes as well. So you might also want to change the label sizes so the characters that really stand out. We can make that, let's say 20. Let's just be a little bit more extreme. Okay, that's maybe a little bit too extreme. Apply. So that brings out the labels a little bit more, and still a little bit more cluttered. So we can still change the degrees, the nodes here. And you can still change this as well to be like 200. And make the minimum size a little bit smaller. Well, yeah. But anyways, you get the idea of where I'm heading with it. So you can see that X-Men cluster coming out a bit more. You can see Wolverine coming out a little bit more, and Storm. So that's pretty much what I wanted to show you. And if you go back to your preview, okay, before we go back to preview, yeah, so that's pretty much what I wanted to show you. It's basically how to start editing in Gephi. And if you go to your preview pretty much says this is how it's going to look like if you save it. And you might still want to manipulate it in this view as well and format it so that it's a little bit less cluttered. And one way of doing this as well is you can add labels by clicking here, but it's going to be such a mess. And you could reduce the label sizes. It becomes a little bit very admin intensive. I don't know if that's a great word, but it becomes a little bit of more work just trying to structure the network and format it and yeah, make it look pretty. It requires a little bit more time. And one thing you can say as well is you can rescale the edge weights as well, so that it's a little bit cleaner. So that's something that's very useful as well. And if we go back to our laboratory, we'll see that the format here, it hasn't changed. And it doesn't necessarily always mean what you do here reflects what you do here as well. So that's something that's I don't really like so much about Gephi. But if you are happy with the way this format looks, you could go and save it as a PNG file or PDF file. And let's just save it on my desktop for now. So let's just say, just call it Marvel. Okay, Marvel C. So you can save that and it will appear as a object on computer. Okay, so there you have it. This is what your image would look like. I just opened it, the Marvel C PNG image that we had. You can copy it and paste it and use it in different applications, or you can go back and manipulate it and spread out the words a little bit more, change the colors of the background, all of that stuff, which is depending on your needs, which would be unique to everybody. So this is the network. Another cool thing I wanted to show you is how you can filter this by, let's just do this first. Let's where is it? Label, adjust, run. See, it'll spread out all the different characters. It's pretty mesmerizing sometimes. So where was I? Yes, I wanted to show you can filter it by community. If you just go to attribute equal, which I find this quite useful, especially if I want to edit a specific structure of a community. And then if I want to add it as a subfilter, I can add it as a subfilter. But if I just want to, but I'm not gonna, I don't necessarily want to put it as a subfilter at the moment. But I think I did drag it as a subfilter, did I? No. So if I go to modularity and I only want to see this specific cluster, which is 0, I would go there. If I want to see another one and explore that, and that's how I would do it. And if I want to take a particular cluster and isolate it from the rest, this is quite a nice hacking trick as well. You could do that, and like if you really want to isolate and spread out all of your clusters away from each other, and just play around with a little bit of formatting and editing, so you've like really spread out different clusters. It doesn't look that pretty, but it could become very useful when you want to isolate, when you have maybe not such thick edges and you really want to separate the different communities. You would use that feature. So that is my tutorial, and if I want to start again from scratch, that's all I would do. And I hope that you have found this useful, and I hope that you will play around more with this example and play around more with different types of networks and data. You don't always have control of what the structure of the network would look like and how pretty it would look or how artistic it's going to be, because it's all dependent on the data and the relationships between characters and all the pre-processing that you've done in R. You could always change this network structure by adding a different measure for the edge weight, such as correlations, and that might reduce the edge thickness as well. And yeah, so that's pretty much my demo for you, and I hope that you have found this useful, and I hope that you are going to be excited to create your own network plots. So thanks. Oh, I would also like to say that this is my first YouTube video. I mostly publish my content on Instagram as Samzy Codes, so you can follow at Samzy Codes to get a idea of what my new content is, and that's where I usually make a lot of news feeds and publish most of my data science content, as well as a little bit finding out more about myself and the day in the life of a data scientist. So if you're interested, you can follow my Instagram profile at Samzy Codes. And I specifically wanted to show this content visually because I don't think there's any other way of giving it justice. So yeah, follow me at Samzy Codes, and don't forget to also check out my GitHub so you can reproduce this and have fun playing around with network plots.